Okay, lesson 13 activities. So we've got some guidelines on how to choose a trig substitution and some identities that might come in handy. So we'll keep those in mind as we work through these integrals. The integral of 1 over 25 minus x squared dx. So I'm going to let x equal 5 sine theta, which means that dx is 5 cosine theta d theta, and I substitute. So I have the integral of 1 over the square root of 25 minus 5 sine theta squared, and then replace the dx with 5 cosine theta d theta. So this becomes the integral of 1 over the square root of 25 minus 25 sine squared theta times 5 cosine theta d theta. Factor out a 25. And I get 1 minus sine squared theta. And then times 5 cosine theta d theta. Replace 1 minus sine squared with cosine squared. Okay, and now I can take the square root. Because this is a product, I can square root each factor separately. That is not allowed for a sum or a difference. So when we were up here, we could not have done the square root of 1 minus the square root of sine squared. That's not allowed. Once you have it as a product, though, you can take the square root of each factor separately. So this becomes the integral of 1 over 5 cosine theta times 5 cosine theta d theta. My 5 cosine thetas cancel, and this is the integral of 1 d theta, which is theta plus c. Now I have to replace theta. So I have to remember my original substitution was x equals 5 sine theta. So I'm just going to solve that for theta. So sine theta equals x over 5, which means theta is the inverse sine of x over 5, or the arc sine, whichever you like to use. So this is the inverse sine of x over 5 plus c. Okay, so that one was pretty much just like the demo. Now we'll do a couple that have some interesting twists. Okay, so this one, we've broken the steps down to help you through it. According to the guidelines, we should let x be 4 tangent theta, because there's a plus here, which means we should use tangent. Okay, so that means that dx is 4 secant squared theta d theta. And I'm going to replace all of the x's and the dx's in the integrand with the expressions we just wrote and simplify. So this is the integral of 1 over x squared, but instead of x, I'm going to do 4 tan theta. 4 tan theta squared times the square root of 16 plus x squared, but instead of x, I'm going to use 4 tan theta. And then times dx, which is 4 secant squared theta d theta. Now I'm going to simplify, and my goal is to get this expression. Okay, so 4 tangent theta squared, that's going to become, so I've got 1 over this whole thing, 16 tangent squared theta. And then I have the square root of 16 plus 16 tangent squared theta times 4 secant squared theta d theta. Okay, under the radical, I have a 16 in both terms, so I'm going to factor it out. So I have the integral of 1 over 16 tangent squared theta times the square root of 16 times 1 plus tangent squared theta times 4 secant squared theta d theta. And then 1 plus tangent squared, there's a trig identity that lets me replace that with secant squared theta. So integral of 1 over 16 tangent squared theta times the square root of 16 secant squared theta times 4 secant squared theta d theta. And I'm out of room, so I'm just going to move into this next part here. This is the integral of 1 over 16 tangent squared theta times square root of 16 secant squared theta. Those are both perfect squares multiplied together. I can do them separately, so that's 4 times secant theta times 4 secant squared theta d theta. Now I'm going to cancel some stuff. So my 4's cancel. And one of these secants cancels with this one. And I get 1 over 16 times the integral of 1 over tangent squared theta times secant theta d theta, which is where I was trying to get. This was where I was trying to get. So that's exactly what I've got. Then my next set of directions says to convert all trig functions to sines and cosines and simplify. Okay, so continuing. 1 over tangent squared is cosine squared over sine squared. So I have 1/16 times the integral of cosine squared theta over sine squared theta times secant, which is 1 over cosine d theta. Now one of my cosines cancels. That one cancels with one of these. So I have 1 over 16 cosine theta, integral of cosine theta over sine squared theta d theta. Okay, so that's where I was supposed to get for that one. And then use a u substitution to finish integrating. So I'm trying to integrate this. I have a sine and a cosine that both show up in the integral. Sine and cosine are derivatives of each other, so those make good options for u substitutions. So I'm going to let u be sine theta, which means du dx is, du d theta is cosine theta, which means that d theta is du over cosine theta. So when I do my trig substitution, I get 1/16, not my trig, my u substitution, times the integral of cosine theta over u squared times d theta, which is du over cosine theta. So my cosine thetas cancel, and this becomes 1/16 the integral of u to the -2 du. 1 over u squared is the same thing as u to the -2. And then I'm just going to integrate using the power rule. So this becomes 1/16. I'm going to add 1 to the exponent, so I get u to the -1, and then divide by the new exponent. So this becomes 1/16 negative times 1 over u, and then replace the u with the sine theta. So this is -1 over 16 sine theta. Should have had a plus c here. Plus c plus c. Okay, so now we have to translate the answer from thetas back to x's, right? So I did the integral. I've done the integration step. I took an antiderivative, but the answer I came up with has thetas in it, and I need it to have x's in it because that's what my original integral had. Okay, so we start with our original substitution that x equals 4 tan theta, divide both sides by 4, so we get tan theta equals x over 4. So then we use our knowledge of right triangle trigonometry and our answer from above to label the lengths in the right triangle. So tangent of an angle is opposite over adjacent. So my opposite side is x and my adjacent side is 4. And then I'm going to use the Pythagorean theorem to find the length of the third side. So I know x squared plus 16 has to equal the hypotenuse squared, call it h. So h is the square root of x squared plus 16. Then I use that right triangle to evaluate the sine of theta in my antiderivative, right? So my antiderivative was -1 over 16 sine theta plus c. And then I'm just going to replace sine theta with the expression that is opposite over hypotenuse. Sine theta in a right triangle is opposite over hypotenuse. So this is going to be -1 over 16 times the opposite side is x. The hypotenuse is the square root of x squared plus 16 plus c. And that's pretty decent, but I can simplify this a little bit. This is -1 over 16. And then instead of dividing by x over the over radical x squared plus 16, multiply by its reciprocal. And I get negative radical x squared plus 16 over 16x plus c. Okay, last problem of the activities. I want to find the antiderivative by making a trig substitution. So x squared plus 49. That's an x squared plus an a squared, which means I should use the trig sub a tan theta. So 7 tan theta, which means that dx is 7 secant squared theta d theta, and I sub. So this becomes the integral of 1 over x squared is 49 tangent squared theta plus 49, and this is all to the 3/2, and then times dx, which is 7 secant squared theta d theta. All right, I'm going to factor out a 49 in this denominator, so I have 1 over parentheses 49 times tangent squared theta plus 1, it's all to the 3/2, times 7, oops, forgot my integral sign, times 7 secant squared theta d theta. Replace tangent squared theta plus 1 with a secant squared. And that is still all to the 3/2. Okay, so now I can take each of these factors in the denominator, raise them each to the 3/2 separately. So 49 to the 3/2. Remember that a rational exponent, the bottom number is the root, so it's a square root and then cubed. So I'm going to take the square root of 49, I get 7, and then cube it, and I get 343. Yeah, 343. Okay, so this is the integral of 1 over 343. That's 49 to the 3/2. And then secant squared to the 3/2. The squared and the half part cancel because the 2 in the denominator is a square root. So that cancels with that, and you end up with secant cubed theta. And then this is times 7 secant squared theta d theta. So these secant squareds cancel with 2 of these, and I'm left with the first. And then 7 over 343, that's going to reduce to 1 over 49, and I'll pull it out of the integral. And I'm left with 1 over secant theta d theta. But 1 over secant is just cosine, so this is 1 over 49, the integral of cosine theta d theta, which is 1 over 49 sine theta plus c. Now I have to replace the sine theta with an expression involving x's. So I'm going to use the same trick as earlier with the right triangle. Draw a quick right triangle, put in theta. My original trig substitution was that x equaled 7 tan theta, which means that tan theta is x over 7. So that is opposite over adjacent, x over 7, which means my hypotenuse is radical x squared plus 49. So sine of theta is opposite over hypotenuse. So I'm going to plug that in here. This is 1 over 49 times opposite x over hypotenuse, radical x squared plus 49 plus c.